Hello, my name is Neil Garrett, and we're going to cover two tools for measuring the depth or extent of corrosion damage. First, we have the depth gauge push pin style dial indicating, and second, the optical depth micrometer analog style. Let's take a closer look at some of the features of the depth gauge. The depth gauge has a base, an indicator pin, a rotating bezel, an indicator pin plunger, and a bezel locking screw. The dial face is normally divided into 1/1000th of an inch increments and can measure a total depth of 0.125 inches or 2.5 full rotations of the indicator. Now that you know the features of the depth gauge, let's proceed to measuring corrosion depth. It is important to note that flat surfaces are measured differently from curved surfaces. For a flat surface, you must first ensure the depth gauge is reading 0 and be sure the pin indicator is touching the undamaged surface adjacent to the damaged area to be measured. Next, you are going to want to move the depth gauge across the top of the damaged area, testing several locations to find the deepest damage measurement. When working with a curved surface, you will need to take measurements on both sides of the damaged area and calculate the average measurement of the undamaged area. You will add the measurements from both sides of the damaged area, divide that sum by 2 to get half of the measurement, then subtract that number, half of the sum of the measurements from both sides of the damaged area, from the average measurement of the undamaged area. Using the depth gauge is not a very complex process as demonstrated in this video. You should now be able to perform damage evaluation measurements using this tool. Now let's talk about the optical depth micrometer. The optical depth micrometer is a useful tool for measuring the depth of scratches and pits, and it can be used to measure the height of protrusions or spurs. The optical depth micrometer has the following parts: a viewing eyepiece, a thimble, a base, and an objective lens. The scale on the optical depth micrometer is a vernier, nonlinear scale that can measure to 1/10,000th of an inch, 0.0001. The eyepiece may be able to be changed out for 10 times or 20 times zoom, depending on what is provided in the kit. It is important to note that the wearing of eyeglasses makes achieving the correct focal point challenging due to the offset distance from the eyepiece. Also, measurements made by different maintainers may not be the same, and all measurements should be made by the same maintainer for consistency. When using an optical micrometer, the first step is to obtain a zero measurement to zero out the tool. To do this, place the optical micrometer over an undamaged area adjacent to the damaged area to be evaluated. Using the thimble, slowly rotate it until the substrate material can be viewed clearly or in focus. At this point, the optical micrometer is considered to be zeroed out, and the measurement should be recorded before shifting to the damaged area. This is recorded as measurement A. This is an example of what you should see when the optical micrometer has been focused in on an area. After zeroing the optical micrometer, move it over the damaged area. To aid in centering the optical micrometer, you can shine the flashlight provided in the kit through the eyepiece to provide a point of reference. Once over the area to be evaluated, using the thimble, slowly adjust the optical micrometer to bring the deepest point of the damaged area into focus. After getting a clear view of the deepest point of damaged area, record the measurement. This is recorded as measurement B. After all the measurements have been made and recorded, to find the depth, you will subtract measurement A from measurement B. The result will give you the depth of the damaged area. If you were measuring a spur or other protrusion, to get the height, you would subtract measurement B from measurement A. If you have any additional questions on how to use these tools, please contact your local NATEC site because we're here to help, or refer you to the November Alpha, Tech 01, Tech 1 Alpha, Tech 509, Volume 2, Chapter 3, Cleaning and Corrosion Control of Aircraft for more additional information.